Good afternoon, ladies and gentlemen. I am Rajesh Kumar Singh, General Manager Production at ONGC, now posted in Mumbai. And this case study, which I am going to present today, it belongs to my tenure at Mehsana Asset when I was posted as in charge of one of the group gathering station. So as you can see, case study on implementation of an innovative scheme to safely attend leakage in process piping of a gas without plant shutdown and without wells closure. The crux of this study is only this, because piping leakages do happen and it will keep on happening. But in this case study, the important aspect is we completed or attended it without plant shutdown and without closure of any well. So due to time constraint, I am skipping some few slides. So this, if we talk about overview of the facility, this is a typical block diagram of a group gathering station. This group gathering station has unique feature that it is group gathering station cum CTF. So it has wells connected to it also along with the bulk storage facility. So there are few areas. First you can see from the left hand side is manifold area, where 3-4 types of wells are connected. One is HP high pressure well, then low pressure well. Then for testing stream we have some facility, and we have a facility for very low pressure wells like activation. Now these streams individually is taken to a preheating and separation section, and from separator all the liquids are combined and sent to a free water KOD. In free water KOD, we separate all the free waters from that, and it is pumped to ETP through wash tank. And from free water KOD, the emulsion goes to heated heater. But the issue is here is that free water KOD is being operated at very low pressure, at 0.5 kg, to keep the wells pressure very low, to enhance the productivity of the wells. So there are two sets of pump. One is HT feed pump, heated heater feed pump, which pumps emulsion to heated heaters. And one is effluent pump, which pumps effluent water or free water, which is separated from free water KOD to wash tank and then to ETP. There is one stream at the bottom also, you can see there is liquid received from other GGS also. So this is also processed along with the liquid of this GGS cum CTF. I will call here the CTF only in our subsequent slides. So coming to problem statement, what exactly problem is? So it will be better clarity will come from this diagram. If you can see it, this is diagram only the free water KOD area where the problem exists basically. So if you can see, this is our leakage point. If you can see this, there is one inlet header of free water KOD. From inlet header, all the liquid is processed in free water KOD. It is very big vessel, having around 7 meter diameter and around 22 meter length. So all the liquid is routed to free water KOD, and from where free water is separated and emulsion is taken to heated heaters through HT feed pumps. Now if you can see that leakage point, it is not isolable. If you are taking through free water KOD and through pump, and in discharge, HT feed pump discharge, there is STV, shutdown valve, and from STV it is directly connected to bypass line of the free water KOD. Now if pump is running, you cannot isolate this plant. And if pump is not running, you have to shut down whole plant, because there is no other bypass mechanism in the plant process. So this was really challenging for us, how to isolate it and how to do the welding work, and also how to conceptualize a scheme which minimizes or which eliminates future occurring of such problems. So what were the constraints which when we trying to conceptualize the scheme? One more aspect I want to say. This facility of the plant is, though it is 50 years old, but in 2021 the total processing facilities were replaced. So it is a new plant, and from 21 to 22 it was under warranty of EPC contractor. So if you can see what were the constraints, no isolation possibility of affected points, due to non-availability of the bypass or any alternate route. Poor approachability of leakage. We have seen that this leakage point is approximately at the ground level. So welding was very difficult. Then risk of complete plant shutdown, risk of wells closure. Total 141 wells are connected to this installation. And these wells are basically maximum wells are on SRP. So if leakage happens and if we want to conceptualize the plant shutdown, we have to close all the wells. And it is very Herculean task to close all the wells because 140 wells and spread across 10 kilometers of the area. And these wells are onshore wells. So triple SB, subsurface safety valves, are not provided in these wells. So you cannot close these wells remotely. You have to go and close it manually. So it was really a challenge. So time constraint was also there because if you do the plant shutdown and close the well, there is production loss and which no management will tolerate. So always there is pressure from top management to do the building work or to attend the leakage without any plant shutdown to minimize the production loss. So there are cost implications also due to production loss and due to cleaning and restoration of the site. Because this plant is being monitored by DGMS, so we have to take care of all the utmost safety point of view as well as housekeeping of the plant. Now, if you see that there were two leakages in the plant. First one was observed within 1 year of the EPC contract commissioning. So it was basically handed over to contractor for attending the leakage. But what contractor said that we need minimum 4 or 5 hours, but we could not stop the plant. So during first leakage, what we conceptualized is we created a loop. If you can see the left-hand side and top, one dotted line is there. So we diverted all the liquid without processing to storage tanks. It was the first modification, but it has many challenges. Because if you see, because if you do this, the quality issue comes. In 4 or 5 hours of wrong inventory or off-spec inventory going to oil storage tanks is a big problem because we have to reprocess it. And heater treaters having limited capacity, it was a big task for us also, and we compromised on some quality also. Now coming to second leakage. So second leakage occurred within few months of the first leakage, though it was completely attended by contractor. But when second leakage came, the warranty was over. So it has to be attended by us or our crew member. So considering huge impact of the leakage on safety and production and to have a various isolation provision, it was carried out to evolve a different option without compromising on safety. One of the options which we considered was to connect the line which was done in first modification directly to heater treater. But it has certain issues because free water KOD is being operated at 0.5 kg and heater treaters were operated at 2.5 kg. And without operating heater treater feed pump, this 2 kg bag pressure will percolate to wells or manifold. There will result in production losses. Our experience was that 1 kg of pressure increase in manifold resulted in around 50 cubic meter per day of production loss. So for 2 kg, you can understand it's 30 cubic meter of loss. So we eliminated this option and we conceptualized few other options. So to the scheme conceptualized considering availability of following provisions already existing. So if you go through diagram, if you see the green portion, the recycle loop of the ST feed pump which goes to free water KOD, there is LCB, liquid control valve, level control valve, and level control valve has been provided with isolation. It is standard engineering practices, it is provided. We also found that there are 2 line spools, flanged line spools available in the heater treater feed line. So we conceptualized scheme that this can be connected and SDB at the downstream of ST feed pump can be completely closed and free water KOD inlet also can be completely closed, can be taken into account. So this way, the leakage point can be isolated. If SDV at the ST feed pump is isolated, then that automatically that leakage point will be isolated. And at heater inlets, we have separate SDVs, shutdown valves. So we can close those valves and directly connect these green portions. If we connect green portions directly, we can have a loop which is avoiding or which is bypassing the leakage point. So with this concept, we went ahead. But we wanted to be doubly sure before taking this modification. So before finalizing the scheme, a thorough integrity check of all the valves was carried out to eliminate any chance of leakage or bypassing of the valves. For safety, to avoid any hot job, new spools were fabricated at off-site and brought to so that they can be flange fitted. Then both these spools were connected by laying a new piping. A trial run of the plant, it is very important, but a trial run of the plant was done through this new loop so that we can check the integrity of label maintenance inside the free water KOD. We did additional modifications also so that the leakage point itself was isolated, because we rerouted those paths which is connecting at the bypass line. We will show in the diagram. So if you can see the diagram, the red dotted portion, these are the modifications. You can see that LCB bypass line is connected to the heater inlet spool. And that leakage point, we completely removed those piping, and we, from SDV3, the SDV at the ST feed pump, the outlet, we directly connected it to heater inlet. So this gave, in future also such type of problem if happens. First we have a loop at the down of this diagram, you can see. This is a ready loop, though it is temporary loop, but it is ready, which can address the future leakage if so happens. And at the leakage point itself, we isolated. And this new junction at the heater inlet feeder was connected through flange. Earlier joint was welded joint, so this was creating problem. So this scheme completely gave flexibility to the plant to attend the future operation and maintenance. And this way we could attend the problem without any shutdown, plant shutdown and well closure. So we can, key benefits we can derive from this. The innovative scheme has incorporated flexibility in the operation and future maintenance, smooth handling of the future such emergencies, then ease in future maintenance, saving by avoiding production loss. We could save around 1,600 barrels only from CTF, not from the GGS. So the key takeaway from this can be the demonstration of high-level coordination, planning, and execution, innovative and simple engagement solutions, balance between continuous operation and safety was ensured, and this case served as a reference model for emergency piping intervention in future also. This case study demonstrates a unique approach to manage emergencies in live oil and gas piping in future, and which provides guidance to process and safety engineers for safe decision making in similar high-stake challenges. This case study also works as guideline for designers, because if designer had given sufficient flexibility in the design, we could have attended it without doing such modifications. So this is all from me. I want to thank IEW 2026 for giving me this opportunity. Our session chair, thank you, sir, for chairing this session. And my co-author, which is not present, who are not present here, Mr. Amit Misra and Mr. Ayush Jain, I also extend thank you, and thank you all for attending this today's session. Thank you very much.
Thank you very much. We don't, in interest of time, I am advised that we won't have question and answer session yet. If we are left over time at the end, maybe we'll have. All right. So let me now invite Mr. Shah, founder and chief consultant of Innovate ProTech Solutions, to talk about process safety management for new energy sectors.
Good afternoon, everyone. I think my presentation is on the process safety management for the new energy sector. And these little heavy topic. All of you know safety management is little heavy topic, and it is after the lunch. So people may find the good place to sleep. So I have got two assignment. One is to convey my message, and second is to make these presentations slightly more interesting, so that at least you are interested to listen me. And second thing, I will assure you that if you are interested in the safety management, process safety management, and if you are from the new energy sector, then you will not sleep. Take it granted from me. So let me see who all are from the new energy sector out of this audience. I was expecting few startup companies, because last couple of years I did a lot of HSC study of the new energy like hydrogen generation, hydrogen usage in the fuel cell, hydrogen dispensing station, and I found the basic safety fundamental what we used to practice in refinery and petrochemical are not there for those people, being some of them are from the startup, some of them are from the R&D, some of them are from the different background than oil and petrochemical, which are high hazard sector. So I thought that let me make this presentation for the new energy sector, so that it can help them, so that his or their project is not derailed. Okay, so with this objective, I have requested and they agreed for the presentation. I was surprised that when it is kept in the supply chain, logistic and operational excellence, because it is on the HSE, and when it is kept in this session, so then I could realize that yes, new energy we are going to use in the supply chain and logistic, hydrogen usage, EV vehicle. So thinking this thing, perhaps organizer might have kept this presentation in this session. So now let us see what is the process. So we'll keep it slightly interacting. Perhaps you may like to interact. If you don't interact, I will continue speaking, but I will ask you a few questions in between. So what is the process safety management? The people from ONGC or public sector or from the NTPC, all those people might be knowing what is process safety, but the startup people I have seen in my interaction, it was difficult for them. Perhaps at a later stage, they can see these on the YouTube. So basically it is all of you must be knowing that ISO 9000, 14,000, 45,000. So these are all the management system. So this is the PSM is a process safety management system which control. Basically it identify the hazard and control the hazard so that such type of fire and other thing doesn't take place. So the process safety management system is a very it is for low hazard as well as high hazard both, and it has got the different way of looking at it. So PSM is a structured approach, focuses on the hazards of energy and chemical at design, operation, maintenance and the end of the life stage. And this is to be understood by the new energy sector very well. Otherwise, whatever initiative we have taken, one incident can derail the complete initiative by the company. Now, these fundamental, all of you might be knowing if you are from the large company. PSM has got 14 elements. Out of the 14 elements, almost 6 elements are for the personal, 5 elements are for the technology, and 4 elements for almost 4 elements for the facilities, right? And we'll not go into the detail of these 6 elements. The purpose is to avoid any catastrophic incident by the proper management system in all the 14 elements. And maybe one time CCPS have done the complete survey, what is the impact of the process safety management in US. And they found that it increases the productivity by 5% as well as saving by 3%. And working with Reliance for almost 35 years, I also believe that proper process safety management can lead to the saving as well as improvement in your productivity. Improved quality, right to operate, these are all the what has been specified by the CCPS. Now, what is this objective of the safety management framework? So normally startup company, if you see, I'm not talking about the ONGC or NTPC or other public sector. Almost it is a chaotic nature. Lot of people working on some project. So if you have the proper process safety management system, perhaps you will be able to convert this chaotic system of complete new design, scale up to the very say stable system, and which lead to the operational excellence. Normally, say core element of the process safety are PSI, like process safety information. PHA is a process hazard analysis, operating procedure and safe practices, training, competency, mechanical integrity, MOC, etc. And it is essential for the new energy sector as well as the energy transition, because new energy sector is bringing new hazard to our complete say new initiative of the say new energy sector. So you have to convert these hazard, identify the risk, create the system for the risk mitigation is taking place or risk reduction is taking place. Several initiatives can be taken. Although I have seen the international level, lot of such type of initiative is taken. Public sector is also taking this initiative. But I have seen the startup, when I visited those people, it is lagging. Perhaps they have to bring this process safety management into their area. Now, what are the components? Suppose when we are talking of the new energy sector, what are the components? The component can be related to the new renewable energy. It can be related to the green chemical production. It can be related to biofuel production, and perhaps every hazard. Perhaps we have not faced all such type of hazard in petrochemical refinery. There are few more hazards which new energy sector is bringing, and perhaps and it creates a unique safety challenges. Due to new material, unproven design, complex interfaces, and lack of safety knowledge to the young brigade who is coming big way in the new energy sector. Perhaps even if you are from the public sector or large sector, perhaps the people working on the new energy are from the startup or from the small sector, and perhaps you are also exposed to such type of hazard unless you take care at the beginning. So now we will see something on the various hazards. It's a long process of identification hazard, then identification of the mitigating measure, and identification so that you can reduce the hazard to the tolerable level, and they take the corrective actions so that the whole initiative is sustainable till your project is materialized. But I would like to showcase you some of the hazards which can be created by the various new energy sector equipment, what we have seen in this slide. Number one, I would like to show the solar panel. Have anybody seen the fire in the solar panel? It is vulnerable for the fire, and perhaps there are several hazards. I would like to brief those hazards rather than going into detail. Number one is the electrical hazards. It is generating huge electricity, and anyone can be electrocuted because it generates the DC current and then convert it into AC current. So when you are going near that solar panel, if it is not properly connected, then perhaps it can lead to the electrocution to the people. I have seen few case studies. Being a PSM professional, I am getting such type of news every month from the different international companies, and I have seen electrocution hazard is also possible. Fire hazard also can be possible. I will show you some of the pictures at a later stage. Electrical fault is again physical and mechanical hazard, because these solar panels are provided at the elevation, and so that physical and mechanical hazard it can create. Environment and health hazard, because ultimately manufacturing process uses some of the hazardous chemicals. End of the life. So far we have not established a system for end of the life of solar panel. Perhaps we have to work on it. And leaching is one of the hazard. Perhaps it is not so far identified, but it uses some of the toxic chemical. So unless you know these hazards, perhaps you will not be able to mitigate those hazards. Then severe weather condition. Second one is a wind turbine. All of you know worker health safety hazard related to the fall hazard, because wind turbine, there are several case studies where the fall hazard has taken place. Confined spaces, because worker might be working inside these small compartment of this windmill. Then extreme weather, noise and vibration. Environmental hazard, because again end of the life of this windmill is not known. There is a lot of waste is being created. Fire hazard also can take place because it uses a lube oil. I have seen the fire in the windmill on the top of this windmill because of the use of lube oil there. The third one is battery backup. This is also very serious one. Perhaps you have not provided the safe battery backup. Although there are several companies who are providing the safe battery backup, but if it is provided by some of the startup company, it can lead to the fire as well as the chemical exposure. Fourth is the electrolyzer. Again, the fire, because it generates hydrogen, it generates oxygen. Both are vulnerable for the fire. It also generates, there are certain electrical hazard, pressure hazard, because if you are generating hydrogen, compressing, storing somewhere, it can lead to, because electrolyzer hydrogen is now not directly used. You have to compress it and then it is to be used or stored. Chemical hazard in the electrolyzer, that is, if again the very pure water is required. So how you can bring that pure water using the chemical and other thing, as well as other hazards like oxygen risk as well as the personal injury. I am just giving you the brief of the hazard. Perhaps if you know the hazard, you can take few action on that. Hazards of the wind. Hydrogen storage and transportation. These are talked a lot, but when I visited the site where hydrogen storage and transportation, I am really surprised. That is a real problem. What codes, what standard you should use. There are several standards like European or American, or there are several other local standards by the different people. And I have seen a lot of confusion taken place at the site while designing and operation and maintenance. Perhaps you have to look into it, because hydrogen is a typical material. All of refinery and petrochemical people might be knowing very low minimum ignition energy, very large flammability limit, very it can lead to the explosion also. Any leak can catch the fire. I have seen the hydrogen fire in my life 2 times. One was the leakage from the analyzer house, which caught the fire while connection to the analyzer house. And second was hydrogen fire cannot be seen. So if the worker was walking nearby the hydrogen compressor, his clothes got burned without even looking at this, although he was saved. But these are all the hazards associated with the hydrogen. Whereas we have to go into the detail because of the time constraint. Biofuel, perhaps all refinery petrochemical people might be knowing the hazard of biofuel, but I would like to add one more hazard here, that is health risk. A lot of dust generation also takes place while forming generation of this biofuel. So occupational hazards are there. Some toxic chemical we are using in generation of the biofuel. And environmental and land use concern, because biofuel cannot be, it requires a huge space also. And other hazards are NOx emission at the time of biofuel. So, okay, biofuel we have talked. Some of the case study, I have brought some picture from the internet. Okay, I cannot see you the real picture what I used to get from my clients, but these are the picture from the internet. The first picture on the left hand top is a solar panel fire. As I explained you, solar panel fire has taken place. That is in the Saudi Arabia. Second picture is regarding the fall from wind turbine. That was the picture taken from the Oklahoma, USA incident. One more picture, that is the hydrogen explosion due to the oxygen leakage in electrolyzer at Korea. This is a very well documented incident, and it is given in the internet. The fourth one I am bringing to you is a battery fire at Tesla factory in Australia. These are all the large company. Still they are facing this type of, because the hazards are not known. It is a new energy sector is creating more challenging hazard because of the lack of knowledge or lack of design standards available. And perhaps that is the reason we have to make sure that whenever we are entering into the new energy sector, the hazards are known and mitigated. Now, yeah. Now to me, this is a very important. We are at the top end of this bathtub curve. If you see the complete thing, and lot of things need to be done so that our say failure rate is minimized. We can what I suggest here, that don't learn safety by an accident. Safety is not cost; it is an investment. And last slide I would like to show here. That is, this is what we can help you. This is the area. I have got the team of retired people, and we can come to your place for audit, advisory services, capability development, training, and for several other reasons. So my suggestion to you, prepare and prevent, don't repair and repent. Safety is state of mind, and this is our qualification for this new energy sector, what we have done, and other hazardous thing what we have done. And finally, thank you very much to IEW as well as to you for your patience hearing. And
Thank you, Mr. Joy. In interest of time, I'll request the next speaker, Rajesh Kumar Garg from Manager's Process Safety at HPCL-Mittal, and he will talk about digital pathway to process safety independence.
Hello, good afternoon everyone. First of all, I want to thank you, the organization team, for giving HME the opportunity to talk on this interesting topic, that is the distillation journey of PSM in HMEL. So my topic is 21st century pathway to process safety from dependent system to a digital independence. In this session, we will talk about the PSM, how PSM journey has been done in HMEL, how we have moved from a paper to a distillation system. It is a real life example of the PSM journey. So first of all, I will talk about by our organization. It is a HPCL-Mittal Energy. It is a joint venture of HMEL and Mittal Energy. And we have a pipeline at Mundra from where crude oil is being transferred to a Bhatinda manufacturing unit. It is a pipeline almost more than 1,000 kilometers from where crude oil is transferred. In Bhatinda, we have 3 units. One is a refinery having a capacity of 12.5 MMTA. Here it is written 11.5, but now capacity has been enhanced in a previous turnaround. Now we are producing petrol, diesel, ATF in the refinery. Second manufacturing unit is we have a petrochemical plant. We have a world-class dual fuel cracker in a petrochemical where we produce ethylene and other products such as LDTP, HDP. And third is a new one, ethanol plant, which we have commissioned recently, where we are manufacturing ethanol. Now, what about PSM distillation journey, which I am talking about? It is the roadmap which we have done in a PSM in a HMEL. So in this first, you will see the starting in 2014, we have initiated the PSM in HMEL. It is based on OSHA PSM guidelines. And subsequently in 2018, we have deployed all the elements. And in the same year, we are certified by a British Safety Council, first outside the UK, to have get a 5-star rating in a PSM. So it is the first company to get a 5-star rating outside the UK in 2018. Now in 2019, we transit our phase from a compliance base to a risk base. Initially, we are doing a PSM on a compliance base. Now 2019, we change our methodology from compliance base to a risk base. In 2023, we take a one step further to integrate all the digital elements into a single platform that we will discuss later. And subsequently in 2022, we do a data analytic study, big data analytic study, and start working on a proactive data analysis. We are not waiting for the incidents, we take proactive actions to prevent incidents. So on the same line, the replica of PSM of refinery has been implemented in 2023 in a petrochemical. Now it is being implemented in ethanol unit. So it is a framework which we adopted in HMEL. There are 4 blocks and 16 elements. So we will not talk more about that. So it is a structure, organization structure of PSM, which we follow in HMEL. There are 16 elements. Every element is led by the PSM champion or power user. We have actively 500 members which are actively participating in implementing PSM elements, procedures, guidelines. So we work on the philosophy that PSM is by the people and for the people. So now basic question is, what is the need of digitalization? So basically when we started the PSM in 2014, it is a manual work. It is an Excel sheet work. We track every element through Excel sheet. Every work is a manual work, paperwork. Lot of errors are coming. Compliance issues are coming. It is a time-consuming job. Everybody is dependent on PSM core group for the PSM informations. So there is a need that we should transfer from a paper to a distillation form. So it is well said, you can't achieve it if you can't mirror it. So it is a main motive that if you want to mirror, we have to change the philosophy from a paper to a distillation form. So taken one step further, these are the distillation platforms which we have developed in the HMEL. First is the process safety culture. It is what is that? In that we are developing a culture of process safety across the team which is working at the ground level. In this, what is we are doing? We are doing the walkthroughs or listening tours is conducted by a senior management, and the walkthrough observations, listening to observations are being recorded in a SharePoint, and that is very much tracked for the compliance basis through a SharePoint. Initially, it is done through an Excel sheet. Now, second is the employee participation. The main chunk of the PSM is to participate each and every element, every person in a PSM. So we have developed an employee participation digital SharePoint. In that we have selected 38 categories to where we think that everybody should participate, and we have categorized rating the 38 activities into a different form. If you participate minimum in a 15 activities, you will be considered as a good. If you participate in a 20 activities, you will be considered as excellent. Below 15, you will be considered as not so good. So this is also tracked to ensure that PSM should go to the ground level also. So other is the process safety management through which we have prepared a PSI dashboard. It is a technical document management system where we have put all the process safety information. You can check from anywhere in a single click regarding PSM. You don't need to contact PSM for that. Other is for PHA, we have developed a PHA management system where we can track the recommendations and the observations which we put for a PHA when we are conducting a PHA. So other is a operating procedure SOP management system. Other is a management MOC system where whole life cycle of the MOC is put into a distillation form in a document management system. These are the other systems which we have digitalized. That is one of the pain area of the operation is the interlock management system. That is being also digitalized in a alarm interlock management system that is integrated in a MES system. Now we don't need to maintain any hard copy or a register for the maintaining of the interlock bypass. It is automatically fetched into a alarm interlock management system. And other is one of the other thing which we have developed. Now there is no need to use a hard copy checklist. We have developed a checklist into a ODR system where distillation checklists are there, and you have to put a distillation entry. So the hard copy checklist system has been abolished from the HMEL. Similarly, LAR system for audit. Taproot is for instant investigation, and mock tagging and mock drill is conducted through a SharePoint. And these are the screenshots for the different elements which we have digitalized. This is the MES system. You find PSI checklist there. This is a taproot which we do for instant investigation. This is a document management system. This is a alarm interlock management system. This is a LFI learning sheets. So these are the number of digital platforms which we have developed in the refinery. Now what we have achieved from this, we now have turned from a qualitative to a quantitative performance model. Initially we are working on a quality performance model. Now we have turned to a quantity processing model. That process safety indicators, which are initially in the red, now we have achieved in the green color. Now, but still, we have moved from a paper to a distillation form, but still it is a dependent system. Why it is a dependent system? Because lot of platforms we have developed, but they are not communicating with each other. There is a dependency on PSM for data. So what is the need of the hour? That all the elements should integrate and communicate with each other. So what we have done? We have transitioned from a scattered dashboard to a comprehensive PSM dashboard. What is PSM dashboard? Comprehensive PSM dashboard. It is a Power BI tool. What we have done with the help of AI team, with the help of our IT team, we have developed a PSM Power BI, where all the elements are integrated into a single tool, that is Power BI tool, from where you can check the performance of each and every area, each or every unit, each and every element by a single click. There is no need of to contact PSM code team for your area metrics. What we have done further in this Power BI, we have developed a Power BI in your mobile also. Even you don't need to go to a desk and use a Power BI. You can check the performance of your PSM through a Power BI through your mobile also. These are the screenshots of the mobile and the desktop where you can check the Power BI tool. Now what we have achieved? Yes, we have achieved the benchmarking of the performance, improved transparency. We are connected all the elements into a single Power BI tool, but still one thing is missing. What one thing is missing is that lot of data but lack of insights. What we learned, we have a lot of data, we know the power of the data, but missing is the analytic part. We are not able to analyze the data. So what we have done, we transit from a reactive to proactive approach by analyzing big data. The data which we are collecting, we start analyzing that data. What we get by analyzing that data? By analyzing that data, we are able to predict the process safety incident data. By predicting process safety data analysis, we are able to predict proactive what incidents is going to be happening in the refinery. We predict what are the pain areas of the refinery. Big data analysis we have done for process safety incidents, process safety near misses, permit audits, online ceilings, operator safety data, round data analysis. How we are doing the big analysis, I will show. This is one of the example how we analyzing big data. This is the analysis of the near miss. You will see we analysis near miss into different categories by using different algorithms of Power BI. What we have done for a single near miss, you can see what the performance of the refinery year-wise. What is a near miss? What is a source of near miss? What is the category of near miss? What is the classification of near miss? What is the equipment related to near miss? What are the areas where near miss has been done? So what we got from here in our refinery, in our HML, what we have done, for every leak you have to put a near miss. In other refineries, when there is a leak, we attend the leaks by doing a maintenance work. But in HML, there is not a single philosophy. There is a single philosophy that you have to put a near miss. We will analyze that data and we will able to know the pain area. From this, we able to know that there is a pain area of small bore connection from a near miss, and we able to do the rectification of small bore connections in our refinery. Similarly, we able to know the pain area, that SOP is a pain area, by analyzing the big data for incident investigation. So these are some of the examples what we have got from the big data analysis. What we achieved? We achieved from a reactive approach to a proactive approach by analyzing big data. But still something is missing. What is missing? This is a distillation journey. We already talked to you. But it is a journey, not destination. What is missing? Missing is that we still working on the integration of human factor into core of process safety management system. We still are working on that. We are still working on fostering a sense of vulnerability and continuous building process safety competency in our HMEL. What we have achieved? We are shift from a compliance based to a performance based indicators. We have achieved the process safety distillation in HMEL, but other two main factors still we are working on that. This is one of the example. We are every day using ChatGPT. We are every day using WhatsApp. Everybody is saying there is a AI in WhatsApp. We are using ChatGPT. Has anybody think of using that ChatGPT in PSM? No. But here is the answer. HML has taken one step further. They have developed a PSM chat GPT. That is Jenny. That is exclusively for PSM. It is developed by a HML IT team. Here you can get any data of PSM by single using as a chat GPT. So it is very convenient for everybody. They can use the chat GPT and get a data of PSM from anywhere. The other thing which we have done, we have developed a LFI learning portal, sorry. It is open for employees and contractors for everyone. Now what we have done, we have converted all the incidents, all the CSB videos which is published in English videos, we have converted it to Hindi videos. Now it is accessible to everyone. Everyone can use the video. There is a question link also with that. You can you can give your answer and you will get a prizes. There is a leaderboard also. It shows the performance of the unit, which unit is participating, which employees is on the leaderboard. So this initiative also is done in the PSM by HMEL. So this is from my side. Thanks for all listening. Thank you.
Thank you so much, Rajesh ji. Can I ask next speaker, Divyansh Saxena, Manager NTPC, rooted in innovation, floating wetlands for heavy metal detoxification in thermal plant ash water.
Thank you, sir. Very good afternoon to all of you. Respected session chairperson, Sri Satyam sir, and all esteemed speaker with whom I am sharing this stage, and all respected audience. Myself, Divyansh Saxena. I am from NTPC Limited, a leading power generation company of this country. I belong to a power sector. Basically, power sector often come in news. Some are pleasant, some are unpleasant. Unfortunately, all the news on this screen are unpleasant one. These news are related to the heavy metal toxification caused by thermal power sector in the nearby vicinity water bodies. Whether it is Maharashtra or Madhya Pradesh or Punjab, this news comes all across from the country. So, first we should know what are the heavy metal toxification sources are. Broadly, we can classify this heavy metal toxification sources in two categories. First one is natural sources, second one is anthropogenic sources. Natural sources are due to the weathering of sedimentary rocks, whereas anthropogenic sources are due to the combustion of fossil fuels, mining activities, and discharge from industrial wastewater. So, as India is progressing toward becoming a major economy of this world, it cannot be possible without attaining energy security. But in India, we have a large coal reserve. So we are majorly relying on coal-based thermal power plant. Currently, 47.4% of the total installed power capacities of coal-based thermal power plant. And these power plants are delivering 70 to 75% of the total energy demand currently. So it comes with a cost, and the cost is massive ash generation. As we can see, through this power plant, annually 180 to 200 million tons of fly ash is generated. And the disposal of this fly ash mainly done using in the form of ash slurry, and which is transported to the nearby ash slurry ponds. So what are the composition of this ash slurries? Basically, ash content consists of silica, which is 30 to 60%, alumina, which is 15 to 35%, iron oxides, calcium oxides, and with some unburned carbons. But the thing is that it also contains traces of heavy metals like arsenic, lead, mercury, cadmium, chromium, and selenium. In this table, you can see what are the content of this heavy metal in the ash slurry and what are the permissible limits set by BIS and CIA norms. As you can see that arsenic content is 0.25 to 0.4 milligram per liter, which is 2.5 times of the permissible limit. Chromium is 0.4 to 0.6, which is 4 times of the permissible limit. Lead is 0.3 to 0.5, which is 3 times of the permissible limit. Mercury is 0.005 to 0.010, which is 5 times of the permissible limit. Cadmium is 0.5 times. Selenium is 2 times. TCS is 2 times, whereas pH is also increased in this untreated ash slurry mix. So what are the chronic health risks associated with heavy metals? This arsenic is a potent cryogenic compound. It causes lung cancer, skin cancer, and bladder cancer. Mercury, on the other hand, is a severe neurotoxin. It causes developmental disorders, and it also penetrates in aquatic food chain. Cadmium, on the other hand, causes kidney and liver damages. Chromium also causes kidney and liver damages. Lead is also a potential neurotoxin, and in infants it causes development delays. So when this ash slurry is transported in the nearby ash ponds, so generally this ash ponds is constructed near a water body. So when this ash pond slurry overflows, it goes in the nearby water bodies. Unfortunately, these water bodies utilized by nearby communities, which use this water for their household chores and for irrigation also, and thus they face chronic exposure to this dissolved toxins. Various studies were also conducted. The prominent one is conducted in Vijayawada in 2010, in which they took the water sample in this water body, which is situated to near this ash ponds, and they found that post-monsoon, this heavy metal contained in this water bodies surpassed the permissible limit of all the heavy metals. Where regulatory mandates were also given. Prominent ones are given by Central Electricity Authority under ASPON construction in 2022, which states that no discharge of liquid effluent from ash dike into or any surface water body shall be permitted. CPCB, which is Central Pollution Control Board, also provided guidelines under Environment Protection Act in 1986. It states that the testing of bioaccumulation and biomagnification of trace of metals in the surrounding flora and fauna should be conducted pre-monsoon and post-monsoon to track the heavy metal concentration. So we have discussed about the problem. So what's the solution? Actually, we found the solution in nature itself, which is wetland plants. On the screen, you can see some plants are floating over the water. These are called wetland plants. There are various studies which shows that these wetland plants are capable of absorbing heavy metals from minerals, from water and soil. So we have developed a model using the floating treatment of wetland plants, which we are placing on high density polyethylene modular rafts, which are placed over water bodies to absorb this heavy metal from the water. And to further enhance, we move for an hybrid approach by adding a reactive media layer before this floating wetland plants by using zero valent iron, limestone and biochar. So how we can select these wetland plants? Broadly, these wetland plants are categorized in 4 categories: phytoextractions, rhizofiltration, phytostabilization, and phytovolatilization. Phytoextractions are those plants which absorb these heavy metals from water or soil and translocate them in their shoots, which were later can be harvested and safely disposed. Rhizofiltrations are those plants which absorb this from their roots and keep this heavy metal in their roots only. Phytostabilizations are those category plants which immobilize this heavy metal near their root areas, thus prevent them to leach into groundwaters. And phytovolatilization are those plants which took this heavy metal from their roots, but slowly emits them through their leaves into the atmospheres. So for our floating wetland model, we used the phytoextraction category of plants. We have studied various plants and we found these 5 plants very useful for our model, which is Typha latifolia, Vetiveria, Ipmoia, Canna indica, and Phragmites. These plants are selected on the capability to absorb these heavy metals, as well as these are very robust plant. They can sustain in very harsh condition, and cost efficient also. In this model, we have added a hybrid mechanism also by using zero valent iron. These are elemented iron ore which act as a reducing agent and thus reduce and adsorb these heavy metals. Activated biochar is also used. Actually, this consists of reactive sites in which heavy metal can be adsorbed. And limestone is used. Actually, limestone increases the pH and alkalinity in the water and thus precipitate this heavy metal hydroxide and carbonate. And it later also, it actually limestone helps in the floating wetland area because it increases the pH, which further increases the wetland plant capability to absorb these heavy metals. So we developed this model. Actually, this model is suggested by Professor C. Babu. Actually, he used this model in South Delhi Neela Hose Lake to treat the water. So we tailored it according to our requirement to treat the ash water. In this ash water, when overflow from the ash pond, it moves from the inlet trash rake to which remove the trash. Then further it goes into sedimentation tank, which sediment the suspended solid there. And then it goes to this primary clarifier tank, which is constructed using pebbles and sand, which further eliminates the suspended solid, which is smaller in size. Then the ash slurry water goes to that absorber bed, which consists of biochar, ZVI, and limestone, which absorb the heavy metals. And then it goes into floating wetland areas, which absorb the most amount of the heavy metals. And then we can monitor and check the heavy metal concentration in this treated water. So talking about model feasibility, this proposed model actually is a modular type. So it can be scalable. We can upscale and downscale this model according to the dike size and the water discharge volume from the thermal power plant. Thus, this flexibility ensures that it can be applicable at various locations as per their capacity and site-specific requirement. Talking about model design, if we take a 250 megawatt thermal power plant, so total ash generated per day is nearly, we generate 20,000 to 30,000 meter cube of ash slurry per day. And as per the norms, we have to utilize this 95% of the ash slurry. So 5% of ash slurry can be overflow from this ash pond, which comes nearly 100 meter cube per day. So this for treating this 1,000 meter cube per day ash slurry, we required 20 HDP modular raft, which is 5x5. It will cover 500 meter square of area, and 2,500 of plants, microphyte plants is required. And for hybrid model, we required 1.2 meter cube of biochar, 15 meter cube of zero valent iron, and 10 meter cube of limestone. And construction of sediment tank is there, and construction of primary filter using sands and pebbles is also there. So the implementation cost for this model, actually for this modular rafts and microphyte, it comes nearly 5 lakh rupees. For hybrid absorber bed, the cost required is nearly 8 lakhs to 10 lakhs. For sediment tank and this filter construction, it requires 5 lakh to 8 lakhs rupees. So total installation cost comes nearly 20 lakhs to 30 lakhs rupees for this model. And if we talk about the O&M cost for maintenance and operation, this raft, if maintenance requires 50,000 rupees annually, a microphyte harvesting requires 50,000 rupees. Reactive media replacement required 1 lakh rupees, and monitoring and miscellaneous expenses will be around 50,000. So nearly 2.5 lakhs of O&M cost is required for this. Now, what is the final result after implementing this model? As you can see on the screen, all the parameters are drastically reduced after we pass this ash slurry from this model. Arsenic is reduced by 75%. Chromium is reduced by 80%, lead is reduced by 66%, mercury is reduced by 80%, cadmium is 80%, selenium is 75%, TSS is also reduced by 80%, and pH is also normalized. And all these parameters come within the permissible limits set by CPCB. Now, if we talk about the cost benefit analysis of this model with traditional treatment plant, to initialize this treatment plant, we required 2 crores of capital. But for this model, it requires only 25 lakhs. If we talk about the operational expenditure, conventional treatment plant requires 8 to 10 lakh rupees per year, whereas our model requires only 2.5 lakhs per year. If we talk about the chemical usage, the conventional treatment requires very high amount of chemical for treating this water, whereas in our treatment plant, no chemical is needed, only plant is needed. And if we talk about the O&M complexity, actually to run this treatment plant, skilled manpower and mechanical, electrical skilled manpower is also required, and operational skilled manpower is also required. But in our traditional wetland plants, no operation cost is there, only harvesting is required. So at last, actually, I want to say something. Actually, I was waiting in this lounge and I was drinking water in very fancy bottle. So I thought that we all very privileged because we have access to this water, which is very clean and neat. But every community has the privilege. So this actually model can provide the privilege to all the communities residing near the Ashlery Pond. And it can be very useful for this model. By using this model, we can treat large amount of water using this model. Thank you.
Thank you, Divyansh. Can I have our next speaker, Nischal Raunaq Singh, our Manager of Security at ONGC. He's going to talk about enhancing industrial security in the energy sector.
Our session chair, esteemed speakers, seniors and colleagues from our fraternity, a very warm good afternoon to all of you. I am Nischal Raunaq Singh, Manager Security from ONGC, and today I am going to share my thoughts about enhancing industrial security, particularly in energy sector, through AI-driven threat management system. We heard all about the safety parameter and all the industrial landscape, but one of the elements which I found missing was the security. If we talk about energy sector, there cannot be a better platform than India Energy Week to talk about the importance of energy here. Energy is the lifeblood, the backbone of industrial landscape. It provides economic as well as a social impetus to the economic growth. However, this particular energy sector or industrial sector per se is under threat from digitization, remote access, by exposing our security gaps and vulnerabilities. So as we are exposing our OT system, the legacy SCADA system, which were designed in 1999, 2000, with minimal security encryptions, it is exposing our gaps, and then this is leading to a threat which has not been further envisioned. So now we have a physical security challenges, cyber security challenges and safety challenges all together in a coordinated attack as well. The existing security system, what we have, take this into a compartment. What we have, we must be having a cyber security system in our departments. Similarly, there's a department which looks after the physical security. But there is a need to look at it holistically. And for that, we need an integrated system. If we talk about the sectoral insight, the cyber attack on OT and SCADA system since 2020 has increased 300 times. And it's not just about in India. Globally, the energy sector is actually a most vulnerable sector, a critical sector which has been targeted globally. If we talk about the oil and gas in India itself, to just give you an expanse of this, oil and gas sector have about 38,000 kilometers of pipelines across the length and breadth of country. We also operate about 250 plus critical onshore and offshore oil and gas installations. This energy sector contributes to about 4% of India's GDP and directly give employment to about 1.5 million people in India. We are prone to attack. I was talking about the cyber. Similarly, at the same time, the physical attack like sabotage, illegal trapping of the pipeline, illegal tapping is very prevalent among the oil and gas companies. Similarly, there are insider risk of sabotage, subversion, and now with the advent of unmanned aerial vehicle, there is also a chance of drone incursion. The existing siloed security system, what we have today, only deals with a specific element of that, not in holistically. After an incident happens, the average downtime, or the cost of that is about 20 to 50 crore, which is an estimate. What I am talking about is not some rare or blue moon incident. This is happening regularly across the world, whether it may be in Ukraine, whether happening in Iran, happening in India. So if we talk about the recent case studies, a colonial pipeline in USA 2021, and I'm talking about the all major economies and developed countries. So in USA, when it was done, 45% fuel supply were disrupted, more than 5,000 fuel stations ran out of fuel. Cost estimated impact was more than 2,000 crores. Similarly, for Saudi Aramco, it was a well-planned, coordinated attack for 16 weeks planning, and all elements of physical and cyber security were compromised. A German steel mill is also a classic case of 2020. This was the first industrial ransomware attack where entire mill was closed for a significant number of days. So if we talk about these instances, we come to know this is not some rare instance which is happening. This is happening on everyday basis. And I would tell one of the reason for this is when there is some physical security lapse, they don't tell it to the IT guys. When there is a cyber intrusion, we don't tell this thing to our physical security people. Since our security systems are not speaking to each other, so any coordinated attack, which may look in isolation, and if not connected the dots, it will look at a very remote incident. But if you connect the dot, the whole picture, the story will emerge. So why this is happening, if you ask, the reason is as we are going more digitalized, the post-COVID, there is a need for more remote access. Also, the deployment tools, cybersecurity tools are readily available. The ransomware modus operandi is evolving very, very fast. And thus, there is need for this AI-driven integrated threat management system. We need this because for a real-time defense, not a reactive defense. Since this will use telemetry data, CCTV feed, CNN, video analytics all together to give a holistic picture, we will have predictive detection rather than reactive, and anomaly analytics at the same time. Since this will act on a feedback mechanism, so the learning from AI will, and from the operational area, the feed will again bring more information, the data from the field, and then this will be another utilized for learning and relearning, and then validation, and then again deployment. So this will protect our critical sectors, which is very important for the economy of this country, because any attack on energy sector is attack on society. For example, hospital uses electricity for a backup, maybe diesel. Agriculture need irrigation, again electricity and diesel. So any attack on that can have a very rampant ramification. And for a country like India, where we need to develop a resilient system, it is very, very important. Talking about the AI-TMS architecture, the AI-based threat management system. So in this, sensors will be put on the edge, like the sensors of CCTV, telemetry data, vibration sensors. All the sensors what we're using right now will be put together at the edge level. Why we are asking for edge? The reason being, moment the raw data is sent to the central server, in which many companies are doing, the latency is there. There's a time lag. And in industries like energy sector, every second matters, every second counts. Thus, it is important to have sensors on the edge. So anomaly detection happens locally, the insight generation and the reactions happen on a real-time basis. To communicate the alerts to the central server, the communication layer should be there. We should be secure and resilient. Primary layer can be 4G, 5G, LTE. Secondly, we can have a local low power WAN, and then at tertiary level, a satellite communication can be used. But since there will be a multiple layer of communication, there will be latency, there will be redundancy. We will not be dependent on single system. If in case a system fails, still at the edge level, we will be able to react. At centralized level is also important for the reason being the security patches, that the policy framework, all the important industries, especially energy sector, are the part of national critical information infrastructure protection plan. So the policies, the security patches given from there are then subsequently pushed to the premises for a uniform compliance across the premise. Cybersecurity tooling need to be embedded in that system so that not just physical but also the cybersecurity part is then taken care of. This will also have a continuous, since we are using AI, the explainability, the accuracy, and those need to be ensured. And for that purpose, the continuous governing and man behind the machine should always be there. The design principle is scalable. It is like for resilient and continuous operations. If you see off of the architecture, the IT events, the OT events are pooled together, and like the physical security also gives in the loop in this, wherein the data from the, if we say the security information and event management system, the idea is intrusion detection system, and then penetration system data, then if you talk about the networking, similarly if at endpoint detection and response system, all those data can be pooled in, log can be aggregated, and then with the help of AI and our threat intelligence, that can be correlated, and then the alerts can be generated, minimizing the false positive. When we are talking about these multiple data, there is a need for the multimodal data fusion. Why we need data fusion per se? Because the reason is, if we talk about the CCTV cannot see inside the machines. So it's very difficult to see through CCTV where there is a data theft. Similarly, SCADA system cannot tell whether it is a sabotage or just equipment failure. Network system cannot just see whether there is a physical intrusion. Thus, it is important that it all come together to give a holistic picture, and then with this fusion of this thing, we can have a holistic picture and ensure a threat management system. This fusion will enable both, and it will erase the boundary between the cyber and physical, and we will have a complete data. This will give us a proactive threat mitigation capability to us, which is very important, and like also will be using for a context aware. How we are going to, like for this particular data fusing, first of all, there is a synchronization with the time stamped log. Then this data is normalized because different data feeds are coming together, so it has to be normalized. And very important part is the data enrichment. For example, the context of the data has to be fed in, the timelines, the asset where this is coming from. If all these things put together, it gives a very good context aware alerts. The core AI technique being used here is a simple CNN with your video analytics. This will also will be feed in the CCTV. Similarly, the unsupervised anomaly detection system for the SCADA and the OT system brought together. The graph-based analytics will be able to give the understanding for the dependencies in the system and what can be the cascading effect for that. That is equally important to understand the impact of those attacks across the system, across the premise. Further, as I told earlier, with the reinforced learning, these things will be with the machine learning. This will be adaptable. This will keep on taking feedback from the operational data, and then will relearn, will be validated, and then will go for the deployment. I was talking about the edge. The reason is, as I told earlier, time is very critical where an incident can happen. For example, when you see a guy, a batch of individual, buzzing in a restricted area, can happen, isolated incidents. You see in a video CCTV, a guy is walking into a restricted data center. Again, a isolated incident, no picture. Third, you see a network scan, can happen at times, people will not give much attention to. Same time, after 30 minutes, there is a data exfiltration. You see sometimes the system gives such kind of errors also. But once you see all these pictures and you connect the dot, then you see with 98% confidence that yes, there is an insider threat which is trying to take the data away. This is only possible if we connect the dots. For that, because if we take the data to central server and then bring it back, there can be a time lag, and thus at the edge level, this can be more beneficial. Why we need hybrid? Why not only at edge? Reason because at edge, the computing level is less. We will not be able to deploy ML and other things. Similarly, to have an enterprise-wise similar kind of a system, it is important that we deploy the security policies, the guidelines at the central level, which is pushed down to the premises. And also for the resilience and scalability, if one system fails, there is something to take care of through another system. This is the comparative which will be, I think everybody will understand across, right from the data handling to detection methodology, adaptiveness, even for the geographical scalability and planning and drills, how this system will be more beneficial so that it can go for a proactive threat management system. This is self-optimizing system where policies through feedback will self-optimize and then will deploy accordingly. Application scenario, if you talk about an oil and gas sector per se, especially our very valuable offshore assets of oil and gas companies are there in the middle of the sea. For that, an AI-driven video analytics, and similarly for CNN, the analytics, we can detect what we have is something called VATMS in ONGC also, which is called Vessel and Air Traffic Management System. Clubbed with AI, it can give a whole picture. A whole situational awareness can be generated. Similarly, there are so many incidents of pipeline tapping, then the theft from the pipeline. Through an AI-driven system, that vibrations can be detected along with the feed of CCTV and other physical parameters can be clubbed and a whole picture can be generated. Similarly, the same system can be utilized for the safety purpose also and for the predictive maintenance and other purposes, also through emergency preparedness in digital twins. Nowadays, we have learned that through digital twins, the emergency preparedness can be improved by 30 to 35%. As I told earlier, the importance of energy sector, so saving those 30-35% will become very, very important. Also for the governance, national policy and strategic angle, where energy sector plays a very important role to become a national energy policy or 2030 of Government of India. Also the DPDP policy, NCI, PPC policy and those, it is important that our system remains resilient and secured from those kind of threat. So security in these areas is mission critical. It involves, since it involves AI, the oversight is important for accountable automated decisions and thus regulatory compliance comes into play. And for the policy implementation, since I told it will be placed at central level, so those things will be taken care at the central level. For if you talk of the benefit per se, so it will provide an holistic security picture, a unified coverage across the physical, cyber as operational domain at a single dashboard. It will also provide a real-time risk prediction, something we call as the attack likelihood scoring. So on the basis of the historical data and the available data through AI, and attack likelihood scoring can be done, and also the vulnerability probability can be derived. So depending upon which is more prone to, we can then plan this thing. Regulatory compliance in this area is very, very important, so that will take care of that part, as well as every resource is very critical. We are resource scarce. For that purpose, this security resource and IT/OT resource can be optimized to save our cost there also. Thank you so much. Thank you everyone for the patient hearing.
Thank you so much, Nischal. All right. I think, since morning you must have heard that energy security is important, and I think this panel session discussed, all the speakers presented various aspects of assets and infrastructure development, safety and security. In fact, I can say that many of these areas are very important, not just think about energy security, but as well as national security. So if in that context, it's very important. And when we come to talking about pipeline security and cyber security component, one of the things I would recommend that all oil companies should actually collaborate heavily on those areas, because these are not isolated events for one company versus other. If we really want to increase and scale cyber security from edge to all the way to the offices, all companies have to collaborate. Otherwise, you can be, last year's slide was silo, that silo will still remain, right? So with that, I think I will wrap up this session. Thank you, everyone. If you have any questions, you can reach out to these speakers, because I think we have another session here. Thank you so much.